Can sound take the ocean's temperature?
Between 1995 and 1999, the ATOC, or Acoustical Thermometry of Ocean Climate, experiments measured the speed of sound in the Pacific Ocean. Sound sources at 75 Hz were located off the California coast and near the island of Kauai in Hawaii. Detectors were positioned at various depths off the coast of Alaska, near the Big Island of Hawaii, near Kamchatka, Russia, and New Zealand. The speed of sound compared to the speed of light can be observed at a baseball game. A spectator sitting in the outfield bleachers sees the batter hit a ball before she hears the crack of the bat.
What are possible replacements or additions to the standard model?
One proposed replacement is called supersymmetry. Each boson in the standard model has a supersymmetric fermion partner particle, or sparticle, and each fermion has a supersymmetric boson particle. They are called sleptons, squarks, gluonios, and photonios. These sparticles must be much more massive than the standard model particles. At least 480 billion electron volts. At this time there is no direct evidence of their existence. Although the LHC might be able to reach high enough energies to find them. A second replacement is string theory. String theory requires a 10-dimensional spacetime rather than the normal 4-dimensional spacetime. 3 spatial dimensions and 1 time dimension. A string is a tiny closed loop, like a rubber band. In some theories the loop can break into an open length, like a piece of yarn, but in others it cannot. Strings vibrate at characteristic frequencies, like guitar strings. Each vibration frequency corresponds to an elementary particle. If a string theory is to include fermions, quarks and leptons, supersymmetry must exist. The great advantage of string theory is that the graviton, the particle that carries the gravitational force, is naturally accommodated. But, if string theory is to be a theory of quantum gravity, then the size of a string must be the size of the so-called Planck length, 1.6 x 10 to 35 m. That is an unimaginably small length, 10 to 20 as large as a proton. String theories, however, contain symmetries that make their effects felt at larger distances. At this time there is no experiment that could test string theory. If supersymmetric particles are found, then string theory may garner more support.
Do rolling objects experience contact friction?
Whether it is a bowling ball rolling down the alley or a wheel rolling on the road, there is no sliding between the ball or wheel and the flat surface, so there can be no contact friction.
What is a neutron?
Unchanged arced particle in nucleus with mass slightly larger than that of the proton.
When was the first atomic device exploded?
The gadget was a test version of the plutonium bomb. It was installed on the top of a 30-meter, 100-foot tower in the New Mexico desert at a location 35 miles southeast of Socorro, New Mexico, on the White Sands Proving Ground. The explosion, called Trinity, occurred on July 16, 1945. The energy yield was about 20,000 tons of TNT. More than twice what had been expected. The implosion-type bomb was much safer and more effective than the cannon-style Little Boy design and has been used for all other nuclear weapons.
In what units is force measured?
In SI, the metric system, force is measured in newtons, abbreviated N. In the English system, force is measured in pounds, abbreviated lbs.
What is cosmology?
Study of the formation, properties, and future of the universe, galaxies, and stars.
What is a magnetic pole?
Region of magnetic strength at ends of magnets. Always come in north-south pairs.
Who developed radar?
Radar was developed independently in many countries in the 1930s. But, in 1935, Robert Watson Watt, 1892 to 1973, a Scottish physicist, was the leader of a group that created the first radar defense system for the British military. Although a large number of nations, from the United States and Canada, to Britain, France, and Germany, to the Soviet Union and Japan, worked to develop radar systems during the 1930s. The British system of ground-based radar stations were the first to use radar effectively in warfare. By the early 1940s, radar systems were miniaturized enough to be installed in aircraft so that they could engage other aircraft in fights at night. Ironically, Watson Watt became a deserving victim of his own technology 19 years later. According to Canadian police, Watson Watt had been speeding on a stretch of Canadian road and was detected by a police radar gun. Watson Watt willingly paid the fine and drove away.
What are applications of this rule?
Autos and trucks that are narrower and have high center of gravities are less stable against rollover. Football players and wrestlers are taught to get down low and spread your feet apart. This stance follows the low and wide rule, making your body more stable and difficult to knock over. Your opponent, in order to knock you over, would have to exert a force to lift up your center of gravity and then push you over. If you simply stood upright, with your feet close together, you would be tall and narrow, and your opponent would have less difficulty pushing you and your center of gravity.
What is a center of gravity?
Depends on how weight of extended object is distributed. The object's motion is the same as that of a point object in which the gravitational force that acts on its center of gravity.
What are streamlines?
Streamlines are lines that represent the flow of a fluid around an object or through another fluid. Streamlines are often made visible by putting thin films of smoke in the air. They are used in wind tunnel testing of airfoils, wings, and automobiles. A wind tunnel is a closed chamber with vents in the front and rear of the tunnel that allow wind and the streams of smoke that make streamlines visible to pass around an object. If the streamline smoke appears to be flowing in a gentle pattern without breaking up, then the object is considered aerodynamic. If the smoke breaks up upon encountering sections of an object, the flow has become turbulent. If the flow is turbulent, the drag may be increased.
Where would you put the material to be cut if more force is needed to make the cut?
You would put it nearer the pivot. On the other hand, if the material is easily cut, cutting near the tip of the blades provides enough force and speeds up the cutting.
What is inertia?
Inertia is the property of matter by which it resists acceleration. That is, an object that has inertia will remain at rest or will move in a uniform motion in a straight line unless acted on by an external force. In this simple pendulum game called Newton's cradle, lifting one hanging ball and allowing it to drop and hit the second ball exerts a force on the next ball. The force on the ball at the other end causes it to swing out and back, according to Newton's laws.
How did radio communications develop?
An electromagnetic wave with no changes in amplitude or frequency. Carries no information. It cannot be used for communication. The first method of using these waves to communicate was to switch them on and off in regular patterns. Letters were represented by a combination of long and short pulses using what is called Morse code after Samuel S.B. Morse, who developed the code to transmit information over wires, the telegraph. In 1895, Guglielmo Marconi, 1874 to 1937, a 20-year-old Italian inventor, created a device that transmitted and received electromagnetic waves over a 1 kilometer, 3,280 foot, distance. Later improvements to his antenna and the development of a crude amplifier enabled him to receive a British patent for his wireless telegraph. In 1897, he transmitted signals to ships 29 kilometers, 18 miles from shore, and in 1901 he was able to send wireless messages across the Atlantic Ocean. As a result of Marconi's work on radio transmitters and receivers, he was the co-winner of the 1909 Nobel Prize in Physics. Over the next decade, transmitters and receivers were improved enough that they could be installed in ocean-going ships. Voice communication over the telephone had existed since 1876, but if the distance was to be extended, the voices had to be amplified to be heard. In 1906, Lee DeForest invented a vacuum tube amplifier he called the Audion. It took until 1915 for a radio receiver to be sold using Audions. In 1916, DeForest had developed an Audion-based transmitter that allowed dance music to be transmitted 40 miles. A number of other experimental stations demonstrated music by radio, then called wireless. A large number of radio amateurs made significant advances. When the United States entered World War I in 1917, all stations not owned by the government were shut down, and it became illegal for people to listen to any radio transmission. Samuel S.B. Morse was famous for inventing the Morse code that allowed people to first transmit messages over telegraph wires. During the war, radio was used to communicate between ships and between land and the ships. After the war, amateurs were forced to use only one wavelength, 200 meters, 1,500 Hz. Wavelengths shorter than that were thought to be useless for government use. One amateur was able to send signals 3,000 miles. In 1921, transatlantic voice transmissions were made. Companies began to use radio for specialized needs, like to send time information to jewelers to allow them to set their clocks. From 1919 through 1921, radio was mostly used to transmit musical concerts. The first transmission of a football game occurred in November 1919. By 1922, newspapers had developed radio stations transmitting news, weather reports, crop reports, and lectures. Large companies such as General Electric, Westinghouse, AT&T, and RCA began to be involved in developing commercial broadcasting. From 1922 to 1923, as the number of stations grew without regulation, chaos reigned. In 1928 the government announced new assignments in the frequency band 550 to 1600 kHz. Many more assignments were added after World War II, but these regulations are still in use today.
Can quarks be free, or are they always bound in the proton or neutron?
There have been many searches for free quarks, but they have never been observed. The theory that describes the interactions between quarks and gluons. Quantum chromodynamics, QCD for short, says that quarks can never break free because the more that the gluons are stretched, the stronger the force they exert. In this way they act like springs whose force also increases the more they are stretched.
What is pressure, P?
Force divided by area over which force is exerted.
What conditions must be met in order to see a rainbow?
There are two main conditions for witnessing a rainbow. The first is that the observer must be between the sun and the water droplets. The water droplets can either be rain, mist from a waterfall, or the spray of a garden hose. The second condition is that the angle between the sun, the water droplets, and the observer's eyes must be between 40 degrees and 42 degrees. Therefore, rainbows are most easily seen when the sun is close to the horizon, so the rays striking the droplets are close to horizontal.
What is a lumen, lum?
Unit of measurement of luminous power.
What is a wave?
A wave is a traveling disturbance that moves energy from one location to another without transferring matter. Oscillations in a medium or material create mechanical waves that propagate away from the location of the oscillation. For example, a pebble dropped into a pool of water creates vertical oscillations in the water, while the wave propagates outward horizontally along the surface of the water.
If this were the case, wouldn't riding a bicycle do the same thing?
The real reason why a car is a safe place to be when struck by lightning is because most cars have metal bodies, which act as Faraday cages, keeping all the electrical charge on the outside of the car. Since the charge is kept on the outside of the vehicle, the person sitting inside the car is kept perfectly neutral and safe. It is the shielding of the metal car body, and not the rubber tires, that protects people in automobiles.
What is the Fahrenheit temperature scale?
Temperature scales are artificial in the sense that they are related to temperatures important to humans. The German physicist Daniel Gabriel Fahrenheit developed the first well-known temperature scale in 1714, equipped with the first mercury thermometer. Fahrenheit defined a scale in which the freezing point of water was 32 degrees Fahrenheit and the boiling point was 212 degrees Fahrenheit.
Why, then are there 7 colors rather than 6?
It's because Isaac Newton was drawing an analogy between color and musical tones. There are 7 notes in the familiar European scale A, B, C, D, E, F, and G. So, Newton decided there should be 7 colors in the spectrum, and he identified indigo as the 7th. So don't be too disappointed if you can't see it.
Are electrons waves or particles?
The electrons in an atom are not confined to one region of space, but are spread out. They are acting more like waves than particles. In Louis de Broglie, 1892–1987, 1924 doctoral thesis, he proposed that electrons behave like waves with a wavelength given by x equals h/mv, where h is Planck's constant, and m and v the mass and velocity of the electron. The thesis was forwarded to Einstein, who enthusiastically endorsed the idea and recommended that the thesis be approved. De Broglie was awarded the Nobel Prize in 1929 for this work. The de Broglie wavelength is associated with any particle. Although for an object the size of a baseball it is much smaller than the diameter of a nucleus. The de Broglie wavelength of a particle determines its wave-like properties. Just as light photons interfere with themselves in a two-slit experiment, so do particles. The interference of electrons, atoms, and even molecules as large as C60, so-called buckyballs, has been observed, and the measurements fit de Broglie's wavelength perfectly. So, both matter and light can act like either a particle or a wave. This phenomenon is given the name wave-particle duality.
What is an alternating current, AC?
Polarity of the voltage source, and thus current changes back and forth at a regular rate.
What are vocal cords?
or vocal folds. Vibrating source of the human voice.
What is an X-ray?
Electromagnetic wave of very short wavelength or very high energy photons. Emitted by an atom with many electrons that is disturbed by the collision with a high energy particle.
What is the threshold of hearing?
Minimum sound intensity that can be heard, 0 dB.
How do the police use the Doppler effect in radar guns?
The police use the Doppler effect when checking for speeding vehicles. A radar gun sends out radar waves at a particular frequency. As the radar wave hits a vehicle, the wave reflects back toward the radar gun at a different frequency. The frequency of the reflected wave depends upon the direction and speed of the vehicle. The faster the speed, the greater the frequency change. The radar gun determines the speed of the vehicle by measuring the difference between the emitted frequency and the reflected frequency and computing the speed from that measurement.
Does sound travel faster on a hot or cold day?
Air molecules move faster in hot and humid environments due to their increased thermal energy. Since sound relies on molecules bumping into one another to create compressions and rarefactions. Increased speed of molecules makes the sound waves move faster. The speed of sound increases by 0.6 meters per second for every degree Celsius increase in temperature. Water vapor in the air also increases the speed of sound because water molecules are lighter than oxygen and nitrogen molecules. Therefore, on hot and humid days, sound travels faster than on cool, dry days. The following formula gives the speed of sound in air. Speed of sound equals 331 m/s, 1 plus 0.6 T, where temperature, T, is measured in Celsius.
What is shear?
Scissors, also known as shears, use each of their blades to move the object it is attempting to cut in opposite directions. Thus they exert a shearing force on the object to be cut. Earthquakes often cause land and roads to experience significant shearing forces. Pictures of torn-up roads after earthquakes show how one side of a street moved one way while the other side of the street moved in the opposite direction, tearing up the pavement as the parts moved past one another.
What is farsightedness?
Also called hyperopia. Allows only objects far from the eye to be focused on retina. Images from close objects are behind the retina, so they are blurry.
What is a parabola?
Path taken by an object acted upon by gravity that is given an initial horizontal velocity.
What is the normal force, N?
Force pushing two surfaces together.
What are the different states of matter?
The four phases of matter are the solid, liquid, gaseous, and plasma states. Solid phases are found at lower temperatures, as the amount of internal energy increases. The material changes from the solid to the liquid and then to the gaseous phase and finally, under extreme conditions, to the plasma state. Water, for example, changes from ice, its solid state, to liquid water, and finally to steam, its gaseous state. The temperatures at which the phase changes occur depend on the properties of the material. In the solid phase, the atoms or molecules are held in rigid positions by the chemical bonds between them. They can vibrate, but not change positions. When the temperature is at the freezing point, the solid melts into a liquid. In the liquid phase, molecules, or small groups of molecules, can move easily past one another. In most liquids, the spacings between the molecules is slightly larger than in solids, giving them a lower density. In water, however, the spaces are larger in ice than in liquid, meaning that ice has a lower density than water, so it floats. When the temperature reaches the boiling point, the liquid becomes a gas. In the gaseous phase, the atoms or molecules have essentially no forces between them, so they are free to move independently. They are about 10 times further apart than in a liquid or solid, meaning that the density of a typical gas is 1/1,000 that of the solid. To enter the plasma state, one or more electrons must be removed from the atom. Plasmas consist of electrically charged particles. Plasmas are found in fluorescent lamps, in some television displays, in the upper atmosphere, in the Sun and other stars, and in interstellar space.
What is a Pascal, Pa?
Unit of measure of pressure. 1 Pascal is 1 Newton per square meter.
What is rotational inertia?
See moment of inertia.
What is a good insulator of electrical charge?
In an insulator, the electrons are strongly bound to their nuclei and thus cannot move through the material. Good insulators are nonmetals, such as plastic, wood, stone, and glass. Your skin is a good insulator, unless it is wet.
What alternative analog methods are used?
As was described above, modulating a carrier wave produces additional frequencies above and below the frequency of the carrier. These frequencies are called sidebands. There is identical information in the two sidebands, so many radio services filter out one of the two sidebands, resulting in a single sideband broadcast, or SSB. SSB can work with either AM or FM radios. It has half the bandwidth of a double sideband broadcast. So more radios can use the same part of the spectrum.
What is a dispersion?
Light of different colors are refracted into different directions caused by wavelength dependence of refractive index.
How can you represent a vector quantity such as displacement?
A convenient way to represent a vector is to draw an arrow. The length of the arrow represents the magnitude of the vector. Its direction represents the direction of the arrow. For example, you might create a drawing where 1 inch on the drawing represents 100 feet. And west points toward the left edge of the paper. Then the displacement of the house from First Avenue would be represented as an arrow 1.6 long pointing toward the left.
What is a radar?
An acronym for radio detection and ranging.
What causes the northern lights?
Disturbances on the Sun can send large numbers of charged particles into space. When they reach Earth, they disturb the Van Allen belts, causing the belts to dump particles into Earth's atmosphere. There they interact with the gases in the atmosphere, causing them to emit light. The scientific name for this phenomena is aurora.
What is a charging by induction?
Results when a conductor is first polarized by a charged object that doesn't touch it. Then one polarity of charge is removed from conductor.
What is a coordinate system?
A set of axes used to locate an object. Usually defined at the reference location. Cartesian coordinates are three directions at right angles to each other. Usually the x, y, and z directions.
Are there uses for alpha decay?
The decay of uranium and thorium produces all the helium that exists on Earth. Most of the helium is mixed with natural gas and is extracted from gas wells. It is expensive to separate and store the helium, but, given the increasing needs for this resource, for cooling superconducting magnets used in hospital MRI machines, it is an effort that must be made. Alpha-emitting radioactive elements are used in smoke detectors. The charged alpha particles leaving the element are collected on a metal plate where they produce a small electric current. Smoke scatters the alphas, reducing the current, and triggering the alarm.
What is the difference between force and pressure? Why does the stiletto heel of a woman's shoe sink deep into the ground while if she wears a running shoe the heel does not?
The force on the two heels is the same. What is different is the force divided by the area of the heel. The quotient of force divided by area is much larger on the stiletto heel. That quantity is called the pressure. As an example, consider the case of a 110 pounds, 50 kilograms or 490 N. Woman who first wears shoes with heels 1.5 centimeters by 1.5 centimeters. The area of each heel is about 2.2 square centimeters. Assuming that she puts all her weight on the two heels, the pressure will be 500 N/4.4 square centimeters or 4.5 N/cm2. Pressure is usually expressed in pascals. Pa, or N/m2. In this case the pressure would be 1.1 million pascals or 1100 kPa. If she were to wear running shoes with heels about 7.5 by 7.5 centimeters, then the pressure would be only 45 kPa. The pressure of air is about 101 kPa.
Who invented the first thermometer?
Although Galileo, 1564 to 1642, is credited with developing the first thermometer in 1592, his thermometer was open to the atmosphere. So it measured a combination of temperature and atmospheric pressure. It was not until 1713 that Daniel Gabriel Fahrenheit 1686 to 1736, developed the first closed-tube mercury thermometer. Combined with the temperature scale he defined the following year. Fahrenheit made a significant contribution to science.
What happens to the helium balloon that a child releases?
If the balloon is tied tightly, the balloon will expand as its altitude increases. This expansion is caused by the lower atmospheric pressure at higher altitudes. Eventually, the helium's volume increases so much that the rubber balloon breaks, releasing the helium.
What supplies this centripetal force?
Centripetal force must be supplied by something or someone exerting the force on the object. In a rotating drum ride at a carnival, you stand with your back on the drum. As the drum speeds up, you can feel the force of the drum pushing on your back toward the center of the circle. Often the floor drops down and only the force of friction between your back and the drum keeps you from dropping down with the floor.
What is Ohm's law?
In the early 1800s, George Simon Ohm, 1789 to 1854, a German physicist, developed the law that bears his name: the resistance of an object is independent of current through it. Many materials do not obey Ohm's law. For example, when the current through the tungsten filament wire in a lamp is increased, the temperature of the wire increases and so does its resistance.
What is mechanical advantage, Ma?
Output force divided by the input force, Foutput/Finput equals Ma.
What causes motion?
Between 500 B. CE and 1600 CE there were many other ideas developed about the causes of motion. Some said a stone fell because of the weight of a stone. Supposing that weight is a property of the stone. Others, saying the apple is attracted to earth, supposed, like Aristotle, 384 to 322 BCE, that there is a desire of an object to move toward earth. Others suggested that force is something that is transferred from one object to another, as discussed above. Still others, starting with Leonardo da Vinci, 1452 to 1519, wrote that force was an external agent that exerted a push or a pull on a body.
What is gravitational mass?
Mass defined by the effect of gravity on object. Gravitational force divided by gravitational field strength, m equals F gravitation/g.
What is resonance?
Occurs when an external oscillating force is exerted on an object that can vibrate. When the frequency of the external force equals the natural frequency.
How is GPS used?
One very important use of GPS is to send time signals that allow clocks to be calibrated to within 200 ns, 200 billionth of a second.
What contribution did Thomas Edison make to the electric light?
The American inventor Thomas Alva Edison, 1847 to 1931. Tried literally hundreds of different materials as filaments for the lamp. He found that heating a cotton thread in the air left a thin length of almost pure carbon. The carbon filament was connected to wires sealed in a glass bulb from which the air was removed. In 1878 this first practical electric lamp lasted for hours more than any other lamp.
How does this very small gravitational field keep the Moon in its orbit?
The answer, of course, is that the Moon has a large mass. 7.2 x 1022 kilograms, and so the force on it is 2.0 x 1020 n. When we explore orbits later, we'll use this result.
Do all elements have a fixed number of protons and neutrons?
The number of protons in the nucleus of an atom determines what element it is. So the number of protons is fixed. But, the number of neutrons can vary. Nuclei with the same number of protons but different numbers of neutrons are called isotopes. For example, carbon, with 6 protons, can have 5, 6, 7, or 8 neutrons. The isotopes are labeled carbon-11, carbon-12, carbon-13, and carbon-14. A more compact notation is 11C, 12C, 13C, and 14C. Chemical properties in general do not depend on the isotope. There are at least 3,100 isotopes of all the elements presently known.
What is a nucleon?
Generic name of protons and neutrons.
What is an impulse?
The product of force and the time the force is applied.
What are the limits of the Bohr model?
Today's model is totally different from Bohr's 1913 model. Bohr's model could explain only the spectra of hydrogen and helium from which an electron was removed. With some modifications it could also explain the spectra of the alkalis like lithium. From 1913 through 1926 physicists tried to extend the model, with some successes. But the lack of a physics-based explanation of the postulates led to research aimed at a model that was not based on classical ideas like Bohr's. One of the first steps was taken by the young German physicist Werner Heisenberg, 1901 to 1976.
What is an elastic potential energy?
The energy in the squeezed spring or stretched band.
What are the sources and uses of energy in the United States?
The tables below explain how much energy the United States uses per source and where the energy is used. The United States used 99.2 quads of energy in 2009, where each quad equals 1000 billion BTUs. Electrical generation, 39.97 quads, is very inefficient. Only 31.5% of the energy from the source, coal, natural gas, oil, nuclear, is transformed into electrical energy. The transportation industry is also wasteful in terms of energy. With 75% of the energy, mostly petroleum, it uses being wasted as heat.
When will the United States see its next total solar eclipse?
Although the entire United States will not see the eclipse, it will sweep across the country from Oregon to South Carolina on August 21, 2017. Mark your calendars.
What is a shock wave?
Just as a boat moving through the water forms a series of V-shaped waves, airplanes create conical, cone-shaped, waves as they fly through the air. The waves that the airplane produces are waves of compressed air. When an aircraft reaches the speed of sound, Mach 1, the plane's pressure waves that move at the speed of sound overlap each other, creating a shock wave. The shock wave creates one single, loud sonic boom heard by observers on the ground. When the plane travels slower than the speed of sound, The sound waves do not overlap, and instead of hearing a sonic boom, observers simply hear the delayed sound of the plane. You can think of sound waves as being similar to water waves, emanating from a central source and spreading out in a regular pattern unless they are interfered with.
What is the natural oscillation frequency?
A property of an object that can vibrate. Depends on the mass and force that restores object to equilibrium position.
When swimming underwater, why is vision blurred when you open your eyes, but clear when wearing swimming goggles?
Although the eye's lens changes shape to focus images on the retina, most of the refraction of light takes place during light's transition from air to the cornea. When water is substituted for air, the angles through which light is refracted is reduced, producing a blurred image on the retina.
Is there a net force on a polarized object? And can it exert a net force on the charged object, like the cellophane tape?
Yes, because the electrostatic force is stronger at closer distances. Thus the attractive force between the unlike charges is stronger than the repulsive force between the like charges, and there is a net attractive force.
What is a laminar flow?
Flow of slow-moving fluid or object moving slowly through a fluid. Each thin film of water moves slightly faster than the one closer to the surface.
What is a dip needle and how is it similar to a compass?
A dip needle is just like a conventional compass. But instead of holding it horizontally, it is held vertically. It is a magnetic needle used for navigational purposes just like a compass, but is used predominantly when traveling around the North and South poles. Instead of measuring horizontal magnetic deflection, the dip needle measures vertical magnetic inclination. When over the equator, the magnetic field of Earth is parallel to the surface of the Earth. The closer one gets to the magnetic poles, however, the less pilots rely on compasses, and the more they rely on dip needles to tell them how close they are to the poles. The closer one gets to a pole, the more vertical the magnetic field becomes, because it's turning into the surface of Earth. Therefore, when directly over the magnetic poles, the dip needle points directly downward.
What is the timber?
Quality of sound. Sound spectrum produced by an instrument, characterized by relative amplitudes or harmonics.
What is impedance matching?
Impedance is the opposition to wave motion exerted by a medium. When a wave travels from one medium into another, the impedance changes, causing some of the energy of the wave to be reflected back into the original medium. Therefore, not all of the wave's energy travels into the new medium. An impedance matching device between the two media allows for a smooth transition in impedance and reduces reflections.
If the air pressure is 101,300 newtons per square meter, why don't we get crushed?
Since our bodies have air inside them, the air inside our bodies is at the same atmospheric pressure as the air outside our bodies. Therefore, the pressures are equal and we can move quite freely in our atmospheric environment. The remainder of our body is mostly liquid water and cannot be compressed. The same cannot be said for divers. As the divers go deeper and deeper, the water pressure increases. At a depth of 10 meters, 32 feet, it is about twice atmospheric pressure. A diver can breathe in compressed gas to balance this pressure.
What is the coefficient of friction?
Friction force divided by normal force.
What is a generator?
Converts mechanical to electrical energy.
What happens in there is no force?
The equation says that there is no acceleration. That is, if the velocity was zero, it remains zero. If the object was moving, it continues to move with the same velocity. These statements are called Newton's first law of motion.
What is a wedge?
Simple machine used to force two objects apart. Examples are the knife, hatchet, or axe, and plow.
Does my neighbor's motorcycle have to be that loud?
Times, engineers try to achieve just the right sound or noise for a particular product. The product, whether it's a vacuum cleaner, lawnmower, or motorcycle, needs to be quiet enough so as not to cause stress, yet has to have enough sound to seem powerful. For example, muffler technology has the ability to greatly reduce the noise a motorcycle produces. Yet many engineers and manufacturers feel that consumers would not purchase the product if it does not sound powerful enough.
What is an entanglement?
An effect in an atom or nucleus when 2 or 3 photons are emitted. The spin of one photon depends on that of the other, or is entangled with it. Measuring one spin tells you what the direction of the other is.
How do wind instruments like flutes, saxophones, and trumpets produce sounds?
In wind instruments, the column of air is the oscillating object. The musician must create the oscillation. Perhaps you have blown over the top of a soda bottle and created a tone. When you blow, some of the air goes into the bottle. That increased air pressure is reflected off the bottom of the bottle and returns to the top, where it deflects the blown air upward. This process repeats, resulting in a tone whose frequency depends on the length of the bottle. The energy in your breath is converted into the energy of oscillation of the air in the bottle. A flute works in a similar way, where the player blows over a hole in the side of the flute. The other end of the flute is open. The sound wave is reflected because the impedance in the tube is different from that of the room air. The spectrum of a flute contains all harmonics. If the player blows harder and changes the location of her top lip, she can make the flute play 1 or 2 octaves higher. In other words, the fundamental frequency of the flute is increased by a factor of 2 or 4. The frequency of a flute or other woodwind instrument can be changed by opening holes along the side of the instrument. This shortens the length of the oscillating air column, increasing the frequency. In a saxophone or clarinet, the vibrations are caused by a thin piece of wood called the reed. The player blows through a gap between the reed and the instrument's mouthpiece. The pulse of air is reflected off the end of the instrument and returns to the reed, pushing it open to admit another pulse of air. Double reed instruments like the oboe and bassoon work in the same way. The clarinet is shaped like a cylinder. Its spectrum consists of only the odd harmonics, 1, 3, 5, and 7, etc. A clarinet can be played in a higher register by opening a small hole near the mouthpiece that strongly reduces the amplitude of the fundamental tone. The new pitch is an octave and a fourth higher than the lower register. Saxophones are not shaped like cylinders, but like cones. As a result, all harmonics are included in its spectrum. And opening the register key raises the instrument's pitch by 1 octave. In a bugle, trumpet, trombone, French horn, or other brass instrument, the oscillations are caused by the player's lips. The lips act as a valve, causing pulses of air into the instrument, which causes the oscillations in the air column. In a brass instrument, the fundamental tone is absent. By adjusting the tightness of the lips, the player can cause the instrument to play at the second, third, fourth harmonic, etc. The valves on a brass instrument add small lengths of tubing, lowering the pitch. In a trombone, the length of the tube can be varied continuously, allowing any frequency to be played. The spectrum of a brass instrument depends strongly on its pitch and loudness. The louder it is played, the more energy there is in the higher harmonics. Some synthesizers like this one use keyboards to select the sound to be generated, while others use computers. The ability of a synthesizer to imitate various instruments is accomplished using frequency-modulated synthesis to create voices.
What were uses of the Leyden jar?
In the late 18th and 19th centuries, people attempted to use the Leyden jar in a variety of ways. Some felt that it could cure medical ailments, and many doctors used the jar as primitive electroshock therapy. Others used it as a demonstration device and for entertainment purposes. Still more people felt that it could be used in cooking. Try cooking a turkey with an electrical spark.
What is the Kelvin scale?
The Kelvin temperature scale, developed by William Thomson, Lord Kelvin, 1824 to 1907, in 1848, is widely used by scientists throughout the world. Absolute zero is the temperature at which thermal energy is at a minimum. Each division in the Kelvin scale, called a Kelvin, K, is equal to a degree on the Celsius scale, but the difference is where zero is. In the Celsius scale, 0 degrees is the freezing point of water, while in the Kelvin scale, the 0 point is at absolute zero. Therefore, 0 degrees Kelvin is equal to minus 273.15 degrees Celsius, 0 degrees Celsius is equal to 273.15 kelvins. The Kelvin scale is used for very low or very high temperatures when water is not involved.
What is the boiling point?
Temperature at which pressure of the water vapor equals the atmospheric pressure.
What are examples of levers?
The first class lever shown above has a mechanical advantage greater than 1.
Why are sunrises and sunsets often orange or red?
During the evening and early morning, when the sun is lower in the horizon, the light that the sun emits has to travel through more of the atmosphere to reach us than it does during midday. When the path through the atmosphere is shorter. Since the distance through the atmosphere is much larger for sunlight in the morning and evening than during midday, more of the shorter wavelengths of light are scattered out of the direct light from the sun. Thus the sun's color goes from yellow to orange and finally to red. Dust and water vapor in the atmosphere enhance this effect, making sunsets even redder.
What is a Higgs particle?
Hypothesized particle associated with the mechanism that gives rise to the masses of the quarks, leptons, and the two weak interaction bosons, the W and Z.
What is overtone?
Mode of vibration R is not a whole number multiple of the fundamental frequency.
What other major force can be experienced by structures?
A torsion force, usually from winds, is responsible for twisting structures. Buildings, bridges, and towers use cross supports to prevent such forces from damaging the structures. For example, the John Hancock Building in Chicago has visible cross supports.
Are there federal standards for using hearing protection?
Federal regulations mandating the use of hearing protection in the workplace state that if an employee works for 8 hours in an environment in which the average noise level is above 90 decibels, the employer is required to provide free hearing protection to those employees. For example, many high school and college students work for landscapers in the summer. Since the average decibel level for a lawnmower is about 100 decibels, and if the employees are working for 8 or more hours per day, free earplugs or earmuffs must be provided to the employees.
What is latent heat of vaporization?
Energy involved in change from liquid to gas.